All right, here we are, section 10.4, inscribed angles and polygons. Okay, up until this point, we've looked at what we call a central angle. Okay, a central angle. A central angle, you remember, has one of its vertices at the center. So a central angle in this circle right here, a central angle in this circle right here, would have its vertice here at the center. So again, it would look something like this. This angle right here that it rotates through would be a central angle. Okay. In this section, we're going to talk about a different type of angle, which is an inscribed angle. So how an inscribed angle is different is its vertice isn't on the center. It has its vertex on the circle. Oh, sorry. On the circle. Okay, so it has a vertex on the circle. So, meaning here, if I have this if this is my vertex right here. Oh, why does it keep doing that? Vertex right there. Okay, what are these dots? I didn't mean to do those. An inscribed angle would look like, let's say, this. So it's this angle right here that goes from here to here. This is my inscribed angle. And so this angle here intercepts an arc. There's an arc over here. There's this arc that goes from here around to here. We have that arc there. If this was point, let's go A over here, B, and C. This arc here is what we call an intercepted arc. So an intercepted arc is just strictly an arc that lies between two line segments or rays. That lies between two lines, segments, comma, segments, or rays. In this case, it lays between two rays. It lays between ray AB and ray AC. Okay, so there is our intercepted, there is our intercepted arc right there. Okay, so what we say is actually, so this angle B, so with this whole intercepted idea, we would say here that angle B intercepts arc BC. Okay, so angle A, that's angle A intercepts arc BC. Okay, but then we would also say that arc BC, arc BC subtends. So subtend, really what it means is if we have any type of chord or arc, if we have a chord or arc that lies inside an inscribed angle, then we say that that chord or arc, so we could have a chord drawn here, a chord that goes from B to C. There's my chord that goes from B to C. So we would say either chord, so either arc BC, we would say, arc BC subtends angle B, or we could also say segment BC, chord BC subtends angle B. Okay, so that's just a little bit of vocabulary with that word subtend, how we use it. Okay, so it subtends, meaning that it's inside, it cuts across this intercepted angle. Okay, so now to find this inscribed angle, okay, we can actually find the measure of this angle. I can find this angle measure right in here. Okay, it's actually a really neat trick by finding the measure of this chord, from A to B. And again, how we find the measure of that chord is we look at this angle, right? And it's the degree measure of this angle is the same as the degree measure of that. So we find out whatever degree this is, this angle here, okay, this green angle, we'll go green, this green angle in here is going to be 1/2 of that. So whatever this angle measure here is, whatever this arc measure is in degrees, this angle measure is going to be 1/2 of that. So the measure of angle here, the measure of angle ADB, A to D to B. So the measure of that angle, so from A to D to B, the measure of that yellow angle is going to be 1/2 the measure of, 1/2 the measure of this arc right here, this arc right there. Okay, you should have that smaller. There we go. 1/2 the measure of this arc right there. Okay, so we find the measure of that arc, we take half of it, we get the measure of that inscribed angle. Okay, so this is where highlighters are kind of really useful, because sometimes it's hard seeing that intercepted arc. Okay, so here we're looking for the measure of arc DG. So DG, so I'm going to come in and I'm going to highlight DG. So the measure of arc DG is this one right here. So we're looking for the measure of that arc right there. Okay, but if you notice, this angle here subtends it. This angle that goes from D to E to G. So this angle right here, angle D to E to G subtends it. So there's my inscribed angle. So the measure of angle, DEG is 40 degrees. But this is the inscribed angle. So this angle is half of, this 40 here is half of what this one is. So if this one's 40, then that means this one had to have been 80. Because this arc and this angle have to be half of each other. This is always the bigger one, smaller one, okay? Which then also means that this interior angle here, this angle here is also 80 degrees, right? Because that's central angle, because that's how those arc measurements work, that central angle. Okay, so now let's go ahead and let's look at this next one. Okay, so now we want the measure of angle G. The measure of angle G. Angle G, here's refer to CG right here. So angle G would go from E to G to F. So we're going to go E to G to F. So we're looking at this angle right there, E to G to F, this pink angle right here. So this little angle in here. Okay, well, it intercepts this arc out here. It intersects here. I love how I'm going to switch colors so easy. This blue, it intercepts this blue arc. Okay, so this blue arc subtends. So here's my arc, here's my angle. So that tells me this arc is twice this angle, because this angle is half of this arc. So if this arc is 58, then this angle is half of that. So the measure of angle G would be half of 58. So we take 58 divided by 2, and we get 29. So find the measure of angle G, we take 58. Here we would take 58 divided by 2, and we end up getting 29 degrees for the measure of angle G. So we know this is 29 degrees. Again, so then we would know that this angle right here, this angle here would be 58 degrees. So that could help us find, like, let's say I want to know this arc. Well, we know here we have a semicircle, okay? And that's when we'll use in this next one, okay? So now here it says find the measure, extra example 2, find the measure of arc H to M to L. So let's go. We're going to go H, we're going to go to H, around to M, and then to L. So H, around to M, and then over to L. So we're looking at this long, big arc right here. Well, if we notice, this ends at H and ends at L, but makes an angle here with K. So here we have this angle right here. Switch colors. Let's look. We have this red. Let's go red. We have this red angle right here. And we know this angle, angle K, okay, the measure of angle HKL is 109 degrees. But that is an inscribed angle. It's an inscribed angle. So that means that this arc, this blue arc here, would have to be twice the measure of this inscribed angle. So to find the measure of arc HML, I would have to take 109 times 2, which would give me 218. So the measure of HML is 218 degrees. Okay, so then that means that this angle to the center would be 218, right? Oh, not from there. What am I doing? From here, right? This angle, this one around here would be 218. From here all the way around, okay? Flip that a little bit. Hey, and then it says, what about the measure of arc HJL? Okay, so I know you probably can't erase this in your notes, but I'm going to erase it in mine. Okay. Hey, and we're going to now look at a different arc. Okay, so we'll switch colors, switch gears, let's go green. Okay, so now we're looking at arc H to J to L. H to J to L. Okay, but if we look at this arc, H to J to L, okay, and compare it to that blue one that we just had, if we notice, those have to make a complete circle. So if H to M to L is 218, then H to J to L has to be 360 minus that. Okay, 360 minus 218 gives me 142 degrees. Okay, for the measure of, oh, wait, oh, scratch that. Oh, I'm so sorry, guys. I just completely goofed you up. It's talking about the angle, not the arc here. All right, let's get rid of that blue guy again. I was like, that's way too easy. Okay, no. Angle HJL. So we're looking at the angle that goes from H to J to L. Okay, we're looking H to J to L. So we still need that blue guy. Let's bring that back. We know this arc has a measure of 218. We just figured that out. This arc has a measure of 218. Okay, so from here to here has a measure of 218. And we got that from using H to K to L. H to K to L. Okay, but H to J to L is also an inscribed angle there. So it has to be half of what this arc is. Well, if this arc is 218, that tells me that this green angle in here is going to be half of 218. Well, we just took 218 times 2. We just took 109 times 2 to get 218, so 218 divided by 2 would be 109. That tells me this angle is also 109. What do you notice about angle HJL and angle LKH? HJL and then angle LKH. They're congruent because they have the same endpoints here. They intercept the exact same arc. Okay, so this leads us to our next theorem, theorem 10.1. If two inscribed angles of a circle intercept the same arc, then the angles are congruent. So here, I'm going to do a bit of highlighting. Here we have angle ADB, that blue angle there, and we have angle, let's go pink, we have angle ACB. If you notice, they inscribe their endpoints here, this A and this B, inscribe the same arc. It's that same arc here. We have this arc A. Oh, sorry, wrong button. It's this arc A to B. So, since they both intercept the same arc, then those angles are congruent. So then this angle D is congruent to this angle C. Okay, so that can be really helpful. Like here, an extra example 3. Measure of angle C. So angle C, again, goes A to C to D right here. That's 68 degrees. They want us to find the measure of angle B. Oh, switch gears to purple. Measure of angle B right here. Well, angle B goes A to B to D. So if you notice here, they have the same endpoints. They intercept the exact same arc, this arc that goes from A to D. So that means that angle C, and angle B are congruent, so the measure of angle B would also be 68 degrees. Okay. All right, so now to inscribe a polygon. Okay, what does it mean to inscribe a polygon? What it means is all the vertices of that polygon are on the circle. Okay, so if I was to come in here and let's say do a pentagon, okay, if I can put all the vertices of this pentagon on this circle, okay, five-sided, 1, 2, 3, 4, 5, then we say the pentagon is inscribed in this circle. So we would say the pentagon, pentagon is inscribed. Is inscribed in the circle. Okay, so if we're talking about the pentagon, we would say the pentagon's inscribed inside that circle. Okay, if we're talking about the circle, we would say then the circle is circumscribed about that pentagon because the circle contains all the vertices. Contains all the vertices. So if a circle contains all the vertices of a polygon, then we say that the circle is circumscribed about. Okay, so it just depends on whether you're talking about the polygon. Yeah, that polygon is inscribed inside the circle. If you're talking about the circle, sure, that circle is circumscribed about that polygon. Okay, all right. So we actually have a couple theorems that have to do with inscribed things. One interesting thing is if we go back to, again, this previous section, we know that an inscribed angle is 1/2 the measure of its intercepted arc. Okay, so we know that an inscribed angle is 1/2 the measure of its intercepted arc. So if I have a diameter here, okay, this arc is going to be 180 degrees. This arc is 180 degrees, which then tells me that this angle here that intercepts it has to be half of that. So I know then that this angle is 90 degrees. So if a right triangle is inscribed, if a right triangle is inscribed in a circle, then the hypotenuse is the diameter of the circle. Conversely, if one side of an inscribed triangle is a diameter, then the triangle is right. So basically they're saying if I have a right triangle inscribed in a circle, then that means the hypotenuse is a diameter. Or if I know that I have a diameter and this is a triangle, then I know that triangle's right. Okay, so that's with the triangle. Now, if I have an inscribed quadrilateral, again, quadrilateral, this word quadrilateral here just means quadrilateral means 4 sides. So if I have a 4-sided figure inscribed in a circle, its opposite angles have to be supplementary, meaning this angle E and this angle G have to add up to 180. This angle F and this angle D have to add up to 180 because supplementary here means add up to 180. Okay, so they have to add up to 180. Okay, so here it says find the value of each variable. Well, here I have a triangle inscribed in a circle. And this is the center, so this tells me that this WY is a diameter. Since this is a diameter, I know this angle X is a right angle. So I know that angle X, the measure of angle X, is 90 degrees. But we also know the measure of angle X here is 5X. So 5X equals 90, divide both sides by 5, and 90 divided by 5 is 18. So X would be 18. Right, here we have another one. Here we have a quadrilateral inscribed. So since it's a quadrilateral, all the vertices are on the circle. Then we know opposite angles are supplementary. So if I want to find A here, I know 3A and 111 have to add up to 180. Okay, if we take the 180 and subtract the 111 from both sides, then 3A would equal 69. Divide both sides by 3. 23. A is 23. Okay, now let's go ahead and let's find B. We know B and the 65 would have to be supplementary, so B plus 65 is going to have to equal 180. Subtract 65 from both sides. B would be 180 minus 65 gives me 115 degrees. So there we have B, and here we have A. Okay, the end. There's one little short video with the construction, but other than that, you can get started on your practice.